Hello, everyone. So this is section 1.4 and 1.5. So in this lecture, I am just going to combine these two sections together. So if you see the schedule that I have uploaded on the Blackboard, so 1.4, okay, let me open the schedule first. So I can show you from there. You can find the schedule here and then information tab, and yeah, there is a tentative schedule right here. So if you see the schedule, 1.4 is supposed to be a second week on Monday, and 1.5 is supposed to be on Tuesday, right? But I'm planning, or I'm just gonna do both section and just one video. All right. Uh, so this is going to be both Monday and Tuesday lecture. All right. So that means 1.2. 1.3 and 1.4, 1.5, this section, all of these wave assigned homework are going to be due now this Saturday, coming Saturday, which is August 29, I think August 29, August 29, 11:59 p.m. All right. Actually, this was originally due this last week, Saturday, August, I don't remember, August something. But I extended the due date of this one. So I made the due date of all of these on the same day. All right. So from now on, I'm not going to extend the due date of any of these homework like this. It's just that this is the first week, and also there was some technical problems with the Blackboard and with the emails. So just because of that reason, I think it's a good idea just to extend the due date for this section. All right. So yeah, I will assign. You can see these things we have assigned and the Blackboard. Sorry, yeah, and yeah, you can see there homework. You can see there. So start working on this if you haven't started yet. All right. And also another thing, if you guys enroll in this class late, then again, if you go to the Blackboard, I have, okay, if you go to the Blackboard, if you go to here to this course, okay, so you have everything here you need. You have announcements. So basically, if you enroll this class late, you should watch or you should read all of these announcements I have made. So I did this announcement from August 8, all right? August 17, which was basically the first day of the class, I uploaded a video, all right? So please watch all of these announcements. And also, if you go here, lecture videos, I have created all of these folders. So starting from week one, I've uploaded the week one videos. So please watch all of these videos, and it's just especially, please do watch this introduction video. All right. So if you don't watch this introduction video, you wouldn't know what I expect in this class. So basically, I am doing quiz, right? And I'm doing wave assigned homework, exams, all of these things. And the quiz, I assign it in different way, right? I assign quiz within the lecture, right? So you have to watch the lecture video from this tab, click there, watch the lecture videos. And if you see any, so I have all made a comment on all of these videos below. So if you see any quiz assigned in that lecture, so let's say if you see any quiz assigned in this 1.3, then you have to go to this tab here, quiz assigned in lecture. So this was first week. So if you go to the first week here, week one, I have created a tab 1.3. So if you just click here, you'll see something like this where you can upload your work. All right. If you see that I have assigned any quiz in the lecture, then yeah, you have to upload a work here. If you don't see anything within the quiz, that means probably I didn't assign anything. So you don't have to submit anything, but you have to watch the whole videos to see that. All right. It's just like a regular class. If you were there in class, you would have watched the whole lecture, but instead of regular class, this is online. But that doesn't mean you can skip anything from the lecture. You have to watch the whole lecture to know stuff. And the way I can check whether you are watching my videos is this way. If you so I might assign the quiz any point in the lecture. So that's why you have to watch the whole videos. And if you watch the whole videos, you will definitely see the quiz. And if you see the quiz, well, quiz problems won't be too hard. It will be very simple. So if you see the quiz, you can easily do those quiz within a few minutes, and you will be able to submit your work here. All right, so um, I think it's clear, right? Yeah, lecture videos are here, and you upload your work here. Okay, and especially I'm saying this again one more time just because I saw some of you guys enroll this class late. So just wanted to make you guys clear on this thing. So again, I have so many things I didn't really cover here. So that's why I'm saying you have to watch the introduction videos here, the first videos, which was the Monday lecture. All right, and also you need to watch these two videos as well. All right, so yeah, let's get back to our regular lecture. All right, so yeah, that's what I want to talk about. And also here, if you see any quiz, so again, you have to watch the whole videos to see whether I assign any quiz or not. And if you see any quiz in this video, then the quiz due is going to be, I don't know, I'm just saying it. I don't know if I'm going to assign quiz later on this video or not. Please watch the whole videos. But if you see any quiz assigned in this video, then again, go to this tab, quiz assigned in lecture. And now this is second week. So if you click here, I have already created a tab where it says section 1.4, 1.5. So if you just click there, submit your work. And the work you will see here in the lecture videos, right? Or the quiz you'll see in the lecture videos, right? So, okay, now let's get back to this. Okay, so that's what I want to talk first. Now, okay, now let's get back to the lecture. So this is section 1.4, 1.5. Okay, so here, the first thing I want to talk about is a tangent line. All right, before I talk about the tangent line, I need to talk about a secant line. All right, so, okay, this is a graph. All right, and let's say there are a line. Well, there is a line, not there is just one line. So there is just one line that goes through this graph here at 2 point, here and here. All right. So let's just name these point here P and Q. All right. So this line that goes through this graph, or this line that crosses this graph twice, right? So this kind of graph or this kind of line, we call this kind of line a secant line. Okay. And another one is basically we want to talk here is a tangent line. So the tangent line is basically, let's say, okay, there is 2 point, right? This point is P, this point is Q. But let's say if this point is approaching towards P, or this point is going towards P. All right, let's say this point is going towards P. All right, so if this point goes towards P, what's going to happen? Then in this case, we are going to get just one line, right? If Q approaches towards P, then we will get just one line. So in this case, this line is crossing both points. But if Q is going towards P, then there is just going to be one line that just goes, or that just touches P, right? So there is just going to be one point. Let's just say P is here. Now in this case, we're just going to get just one line. Oops, it has to touch. It has to touch. Yeah, it has to touch this. Let me just go back. Okay, let me just do this, make this line one more time. Yeah, it has to touch just this point P, right? So Q is approaching, or Q approached towards P. That means there is just going to be one line, and this line, or this line is just touching just one point on this graph, which is P. So this kind of line is called tangent line. All right. So be clear on this idea. This is very important. All right. I might ask something like this in the exam. So that's why you need to understand the concept. All right. Since this is an online exam, or basically a kind of a take-home exam, so that's why I keep saying that you need to understand the problems. All right, or you need to understand the ideas. All right. So tangent. That's why tangent line is also called touching, or basically this line is just touching this point. All right. So similarly, let's say, or in this case, the way, so now here, I explained this thing with words, right? But since we're doing math, so we have to write this in a mathematical term. So the way we can write this in a mathematical term is by introducing a limit. So the limit says that, okay, so the limit says that, okay, on the bottom of the limit, we write that the limit, we're saying Q approaches towards P, right? So we're saying Q approaches towards P. Then in that case, we got a tangent line. So the purpose of the limit here is to basically, it says something is approaching towards some point. All right, so that's what the use of the limit. All right, so I'm going to talk about the limit within a few minutes, more about the limit. All right, but yeah, that's the basic idea of the tangent line. So if first starting from the second line, if one point of the second line approaches towards another point like this, then in that case we'll get a tangent line, right? That's how we get the tangent line, and the way we write in the limit form is like this, right? So now talking more about the limit. Okay, so definition of limit. So okay, let's talk this in a detail. All right, so let's say x, y. All right, or simply instead of saying y, we can even say f of x. And the reason we can say f of x is, let's say if you have a graph, let's say this is an f graph, all right, and I can say f of x just because this x inside the parenthesis works as an input. So we have x-axis here, so that's why we say x here, and this function is f of x function, or simply we can say y. Anyway, so let's say on x-axis we have a point A, all right, and if x is A and y, we get L. All right, so now let's look at this again in limit form. All right, so let's say if the limit of x goes to, let's say, A and plus on the top. All right, what does that mean? So A plus on the top means the x value, all right, the x value. So this is x-axis. On this x-axis, well, x values is approaching towards A, all right, and positive means it is approaching from the right. All right, it is approaching. All right, so approaching means it is going towards that point, but it's not going to be exactly that point, but it's going towards that point A from the right. On f of x, or we can even say this graph is f of x graph. All right, so the limit of x goes to a from the right, we have positive in the top of f of x. Then if x is approaching towards a from the right, then we are getting L on y, or on f of x, right? Similarly, let's say the same graph, let's say if x is approaching towards a again from the left, all right, from the left. So that means it's approaching from the left towards a, then that means again f of x is still L. All right, so from the right, from the left, on both cases we got same value, right? So in that case, using these two, we can say that if these two are same from the left and from the right, the limit, then in that case I can say that if these two are same, then x goes to just a. All right, just a of f of x should be L. All right, so that means if you get x goes to a of f of x is equals to L, that means from the right and from the left values are same. So it goes both way. If you have these two same, we can automatically say that a limit of x of just a is of f of x is L. Or from this, we can even say this as well. So it goes both ways. All right. Okay, let's see a few examples. All right. So now, as I explained there, now one thing I want to talk here is, well, here I have this closed circle, right? And here there is open circle, right? So basically the closed circle like this means we are including that point, right? See, I think you learned this in algebra class. And open circle means we're not including. Right, so, okay, so now this graph is given and we need to find this whole thing, all right? So now here, let's see. So the limit of f of x, so let's say this graph is f of x graph, all right? So the limit of f of x, where x goes to 3, well, this is x-axis, right? This is x-axis, this is y-axis. So on x-axis, x goes to 3 from the left. So if x goes to 3 from the left, then y is, well, from left means this line from left, y is 3, right? On y it's 3 if it goes from left. Similarly, on this one, x goes to 3 from right. So from right, now it's approaching, all right? It's approaching, it's not exactly that point. It's approaching towards this point. So on limit, even though we have open circle, we are not including that point, but it's approaching. So that means it is approaching towards this point, right? From left. If x is going towards 3 from right, because we have positives from right, then in that case from right, it's going to be 2. Right? Now, limit of x goes to just 3 of f of x. All right, how do you find this? It's again now this idea. If we get the limit from the right and limit from the left same, then we can say it's the same value. But here, limit from left and limit from right are different, right? Here we got from left, we got 3, from right, we got 2, right? So that's why in this case, since these two are different, so that's why we get undefined. We don't know what exactly it's going to happen if x goes to 3, right? If x goes to 3, we got 2 different answers here, right? So that's why. But what about f of 3, or when x is exactly 3? Like I said, if with the limit, that means it's approaching. But here with this 3, this means x is exactly 3. If x is exactly 3, here, if x is exactly 3, we have 2 points, right? I don't know if it is this point or this point, but now since what we can say here is that since we have a closed circle, which means we're including, so that means at f of 3, we have closed circle. So at this point, we can say that f of 3 is 3. But what about f of 7? That means when x is exactly 7, we have open circle. We don't have any closed circle like this. Here we just have this open circle. So in this case, again, we don't know because we have open circle, so we cannot include this point. So that means it is undefined. All right. Okay, now this one. This is again x, y. Okay, there is this graph. So here on x-axis, this is going towards, this is 0 line, right? So basically on y-axis, this is a 0 line. So this is going towards this line 0. And here it's going towards. On the bottom, that means on the bottom on y-axis, it's going towards negative infinity. On the top on y-axis, it's going towards positive infinity. On x-axis, on the right, it's going towards positive infinity. On x-axis, on the left, it's going towards negative infinity, right? Okay, now here, let's find the limit of f of x. So let's say this is f of x graph. Or this is also actually this graph. If you see this kind of graph, this is also actually 1 over x. So if you see something like this, this means the graph of f of x is equals to 1 over x. But anyway, we don't really need this here. We're just basically, since we know the graph, so looking at the graph, let's find the limit of x goes to 0 from left. So if x goes to 0 from left, this means it's this graph, right? So from left, it goes to 0. X, this is x-axis, it goes to 0. So if x approaches towards 0, right? So again, when I say limit, that means here this x is approaching towards 0 from the left. X is not exactly 0. All right, it's just that it is approaching. So if it is approaching from the left, that means here it's going downward on y-axis, right? Or f of x. So that means it's going towards negative infinity. Similarly, limit goes to x, limit of x goes to 0 from right, because we have a plus on the top. That means it's going towards, from the right, it's going towards now, towards positive. So now from the left, from the right, we got one negative, one positive infinity. Now limit goes to, limit of x goes to 0. Since now from the left and from the right are, these values are different. So that means in this case, we cannot find the limit. So it is simply undefined. All right. So similarly now, limit of x goes to infinity. All right, x goes to infinity. So if x goes to, so infinity means this x is going towards infinity. If x is going towards infinity, what about f of x, or what about y? Here, if this goes to infinity, on the y, it's going towards 0, right? Because on y-axis, right, on y-axis, it's going towards 0, right? So it's 0. Now a limit of x goes to negative infinity. All right, this negative and this negative are different, because this negative means it's approaching from the left, but this negative is out, like it's a negative infinity, right? So it's, these two are two different things, right? Anyway, limit of x goes to now negative infinity means if x goes to negative infinity on x-axis, what about y? Again, 0, right? On y-axis, on y, it's approaching towards 0, right? It's approaching towards this line, so y is approaching towards 0. Okay, now this one, again, let's, so this is f of x. And this kind of SIP is actually 1 over x square. Okay, again, now limit of x goes to 0 from left. So if x goes to 0, so there is a 0 here. So if x goes to 0 from left, means it's going towards positive infinity. It's going upward, right? Positive infinity. And the limit of x goes to 0 from right. So from right, okay, this one is also going towards positive infinity, right? So that means limit of x goes to 0, just 0, means, well, since these two are same, so that means also on 0. So you can simply see that, right? On 0, this one going towards positive infinity, this one going towards positive infinity. So 0 on both sides, it's going towards positive infinity. So that's why also just on 0, it's positive infinity. Similarly, now limit of this, find this, all right? So these two are your quiz problems, all right? One more time, these two are quiz problems, all right? So write this, make this graph, and write an answer, all right? So on the quiz, make sure you make this graph, all right? Just make this graph and write this and write an answer, okay? So I think it's just simple, right? I've explained this on previous example as well. So I guess you can easily do this one. So again, the whole point of this quiz is just to make you guys watch the whole videos. And also I just want to check whether you're actually watching this videos or not. Okay. All right, so now next one, okay, so the next one, okay, so far I explained the limit, I explained the limit with the graph, right? I will, okay, I will also do these kind of problems in section 1.6. But simply, I just want to introduce a little bit. Okay, so let's say we are trying to find the limit of this function where we say x is approaching towards 1. Okay, so what we see here, when we simply say that x is approaching towards 1, that means we can say x is 1. So 1 minus 1 is 0, 1 square is 1, 1 minus is 0. So we get 0, right? So 0 over 0, we don't know that. But what we can do here is something like this. We see that we can cancel something from numerator and denominator. How we can do that is, well, we know that a squared minus b squared is equals to a plus b times a minus b, right? Or we can, so basically using this here, we can also say that limit of x goes to 1, x minus 1 over x squared minus 1, or we can also say 1 is 1 square, right? So x squared minus 1 squared is also, well, using this one, we can get x plus 1 times x minus 1. So now x minus 1, this whole thing cancels, so we get, so every time when you say equal, make sure you write this limit again, all right? Make sure you write, so here, so if you just write this without limit, that's wrong, so you have to write limit. So again, I have to write limit here, limit of x goes to 1. I haven't used limit thing yet, all right? So that's why you have to write limit every time. So on the top, you just get 1. On the bottom, you just have x plus 1. So now after this, you can get rid of limit. So I'm using limit. So now I'm saying limit of x goes to 1. So that means I can say if x approaches towards 1, if x approaches towards 1, then I get 1 over 2. So this whole thing limit approaches towards 1 over 2 if x goes to 1. All right, so this is the answer. All right, so I'll do these kind of problems more on the in section 1.6, but this section was more about the pictures. So looking at the pictures, we need to find these limits thing, all right? Okay, so like I said, I have combined these two sections together, 1.4 and 1.5. So this is basically both Monday and Tuesday lecture. So I'm just uploading or basically combining both lectures in just one video. All right, so that means probably you won't see anything for Tuesday lecture because this is also Tuesday lecture. This is for both Monday and Tuesday, all right? But like I already said, make sure you do your homework by August 29, this thing. I've also made an announcement, so you can check that in the announcement. And also I've sent an email about it. And also about the quiz, if you watch the whole lecture video, probably you will see whether I have assigned the quiz or not. So if you see any quiz, make sure you upload your quiz on the Blackboard. I've showed you guys that already. All right, so I'll see you in the next video. Thank you.